Hi everyone, welcome back to Pine Hollow Auto Diagnostics. We have a fun truck today, a 2014 Ram 2500 heavy duty Cummins Turbo Diesel. Looks like a clean truck. It's only got 60,000 miles on it. Let's read the customer complaint. It was towed here. It's not a beached whale. It does start and run, but it doesn't charge the battery and it has some other issues. Alright, so here's the appointment form that I got for this thing. Truck was driving normal, parked it, 2 days later went to start it up and it had all kinds of codes, including no charging. Truck is currently in another shop in Blairsville, PA. Has been there for 3 weeks. They have done an initial diagnostic, have not found the problem, have not been able to work on it for some reason. At this point I have lost faith in them to do the work. I believe there's something wrong in the wiring harness, as all the following codes popped up all at once, and they are not related to each other. Done some troubleshooting my own, but without a proper scan tool, no wiring diagrams, I can only get so deep into it. Yes, you need a scan tool, you need wiring diagrams. I've watched estimates for years, so guy's pretty close, less than 2 hours away. Here are the following codes. Fuel rail pressure too high, intake air heater control circuit low, injection pump fuel valve high current, cooling fan 1 control circuit low, intake air diverter out of calibration, missing calibration. Here's what I tested and replaced. Had an alternator tested 2 places. Both said it was good. Replaced the tip-em with a new OEM unit. Okay, little part scanning going on. Checked all the fuses. Had the batteries tested individually. They came back good. The truck does run, but without charging I would have it towed to your location. So that's what it did. Showed up yesterday on a rollback. Let's fire it up, scan this thing for codes, and see what's going on. So I went in to plug in my dongle and I see, oh boy, a whole bunch of stuff. So I asked the owner, what's this thing that plugs into your OBD port? He was like, oh, I forgot to mention, this truck is deleted and tuned. I'm like, uh-oh, crap. That definitely adds a variable. He said back in 2018, so the truck's a 2014, and in 2018 it was modified. The program was loaded in there with a tuner, and he's been running it that way for, what, 6 years now, right? No issues, and just now, boom, it just have all these problems all at once. So let's plug in our scanner, see what the computer's fussing about, and see what the issue is. I was gonna say if it was all stock, it'd be like, hey, maybe it's rodent damage, they chewed on a harness, but that's not what it sounds like. This sounds like something to do with the aftermarket tune. Alright, turn the heat on, diesel preheat and process, service electronic throttle control. That doesn't look good. Let's log in, scan it for codes. Okay, so the scanner caught some communication codes just now. The wipers came on, ABS is fussing, so we're going to have some communication codes here, unfortunately. But I'm not worried about those. I'm worried about the hard faults in the ECM. So I did do a health report last night. So, you know, this lost comm stuff we don't really care about. But we do have the P0254 injection pump fuel valve high current, air intake heater control circuit 1 low, no charging codes. Okay, so let me just clear everything out right now, as we know the problem is current. So PCM, cooling fan 1 control circuit low, that's just a hard fault apparently. Let's go back, turn the key off, let it reset, then we'll run it active airbox service required, see dealer. We got some blue smoke going on. Service electronic throttle control. Okay, let's do a smart scan. So 4 codes in the PCM right away. And look, 11.8 volts. This thing is not charging at the moment. So everything else seems to be happy. Let's go right into PCM. So these are the 4 codes that we're going to chase. Metering control A intermittent. Air intake heater control circuit low. Okay. Let's get in here. I want to check the charging data PIDs. Is there a generator? Nope. Alternator. Alternator voltage 11.5, so obviously that's not good. That should set a code. What about charging? No. Sense. Let me just browse through these. I want to get some alternator data PIDs on here. See, there's battery voltage. Just a couple data PIDs. We're definitely, the fuel rail pressure is definitely too high. It's supposed to be 600 bar. We're at 850. So multiply that by 15 to get PSI. Holy crap. That's almost 14,000 PSI. That's crazy. And there is no alternator command data PID for some reason. These new trucks are truly ridiculous. You cannot see anything in front of you. Look where the hood is. There's the roof of my Mystique. Alright, let's get some juice flowing to these batteries while we make a game plan. So dual batteries, I have it set to a max of 50 amps. We could do 90 amps, but this is a nice safe number. So we'll get those charged up. And oh, what do we see here? There's one alternator. I think this thing just has one alternator. And where are the control wires? Down here. Here's the main stud. Here are the control wires. Right here. Let me disconnect those. The owner said that the other shop tried bypassing the alternator control wire, like the field wire from the PCM to the alternator, and it worked. I doubt that. Maybe they just jumped battery positive voltage to there and the alternator would charge. But where do we want to start? We have these high pressure fuel codes, alternator codes, or no alternator codes, but it's not charging. And I'm suspecting a problem with the engine computer, which lives down there on the engine. So we can do a quick check at the alternator. It's easily accessible up here before going too much further. Alright, so I got the alternator completely unplugged. Let's see if it set any codes. And we'll just leave that at 13.5 for now. Alright, let's fire it up. Read fault code. Oh, here we go. Generator voltage sense low. So we did get an alternator code from the PCM. Let me record those. So at least the computer is aware that we unplugged it. But why wouldn't it set that code when we're at like 11.5 volts? That's my question. Okay, let's look up this code that we set when we unplugged the alternator. Generator voltage sense low. Now, here's the schematic. The PCM is in control of the alternator. We just have one. So there's field control and the sense wire. Two wires. And theory of operation. Two communication lines. So I don't know if that's data or just the voltage, like an analog. Based on sense battery voltage, PCM commands the generator to charge the batteries at a desired voltage. The max voltage PCM will command is 14.7. PCM then receives feedback from the generator on the voltage level it is charging the batteries. The PCM will not light the mill with the engine running. Set condition: battery voltage exceeds charging voltage by more than a calibrated amount for a calibratable period of time. Okay. Battery voltage exceeds charging voltage. So we do have a data PID for the sense, alternator voltage versus battery voltage. Okay. Output stud. I mean, when the truck is running, this thing should command the alternator on. So let's look at scan data and plug in this sense wire and see if the scan data changes. Alright, so here's scan data. We have alternator voltage 12.5, battery voltage 13.5, and bus voltage 13.5. That's the charger that I have on there. So let's plug in the alternator and see if this jumps up. It does. So the sense wire is fine. What about the command wire? We don't have a data PID for alternator command in the data stream, I don't think. I can take another look, but what's the easiest way to check if this ECM is corrupted or if there's an actual wiring problem? Okay, so alternator's unplugged. Channel 1 is on the field wire of that connector. Channel 2 is on the sense wire. So we have 0 volts on the sense and 4 volts, I'm assuming, coming from the ECM on the command. Let's just plug it in, see if anything changes. So key is on. Let me double check. Yep, so key is on. Let me reach down here and just plug it in. Easier said than done. Okay, right here. Boom. Okay, so the sense wire is analog, and the command wire went from 4 volts down to 0. Very interesting. Okay, so we know the sense wire is fine, and the alternator is definitely putting out the correct voltage on the sense wire. What about this command wire? Let's plug it in. So it got pulled down to 0. Fire up the truck and see if anything changes. Will the PCM command that alternator on? Alright, let's fire it up. Nope, stuck at 0. And our voltage sense wire is 13.1. So we definitely don't have a command out the alternator. So I want to see if there's any bidirectional controls for this alternator field wire. Alternator test. Okay. Test the output of the alternators. The engine must be running. Okay. Negative response. Let's start up the engine then. Alright, my next check is to unplug the fuel metering valve. It's right here, just the 2-pin plug. Let's see if it sets any different codes. Alright, here we go. It just says high current active, but there's no circuit code for this fuel valve. Fuel rail pressure too high, yes. Okay. Let's see, let's just clear all these out. Okay, so high current, voltage sense low, and cooling fan low. Let me plug those in and see if the codes go away. Alright, plug those in, clear DTCs, yes. 0254 injection pump fuel valve high current is still active. Okay, let's focus on this code now. It's just 2 wires. See why that's being set. Okay, let's read up on this P0254 injection pump fuel control circuit high. Again, PCM, 2 wires, there's that fuel control actuator. This was replaced by the previous shop as a little parts cannon try. Did not work. So I want to get a scope on these 2 wires and how does this thing work. So it provides a PWM driver circuit and ground circuit to the fuel quantity solenoid. PCM varies the current to this valve to provide the correct fuel flow. Fuel quantity solenoid is normally open valve. Okay, so high circuit resistance may cause fuel pressure to be higher than commanded at light loads. Okay, though this is primarily an electrical diagnostic check, fuel supply issues. So apparently with this thing unplugged, this valve is open and the fuel pressure is ramped up to the max. And this thing reduces the fuel pressure. That's that fits our fuel pressure too high code and this control circuit high code. So let's get a scope on both these wires. I mean, it sounds like this one should just be a ground and this one is positive, positive side switched. See what's going on there. We can even measure the current going through this pump. It's right next to the PCM. PCM detects voltage on the K366 fuel quantity solenoid driver circuit when the PWM signal is turned off. It detects voltage on there when it's turned off. Huh. short to voltage. Okay, let's get a scope on there. I want to see what these two wires are doing. Okay, we got the pico scope connected to the two wires. Channel 1 is the positive, channel 2 is the return. Let's turn the key on and see if anything changes here. Alright, so key is on, absolutely no change. They're both, the high and the low side, are at 0 volts. Let's fire it up. Still at 0 volts. So is the fuel rail pressure too high or too low? Oh, there we go, 600 bar. So we're not in control. Obviously we're not in control. Let's unplug that solenoid just in case. And if that stays at 0, we're done. This thing, the computer drivers are messed up. You can't put out voltage to the alternator. Can't put out voltage to this driver for the fuel solenoid and whatever else. Yeah, it's looking pretty bad for the ECM. Alright, here we go again. Solenoid's unplugged. No change. Engine computer. That's what I suspected, and I don't think a reflash is going to fix drivers that aren't putting out voltage. The computer expects voltage on there, and it's setting a code, but the actual driver, transistor, whatever, is messed up. Not a software problem, unfortunately. Last thing we have to do is check powers and grounds. I'm going to look up, make sure there's no blown fuses or something weird. But yeah, this is unfortunate. And this ECM, holy crap, $6,200 for a computer. That's insanity, plus programming. So this is actually a very high stakes call to make. And if you're willing to gamble like that with tuners and aftermarket crap, that's how much you're gambling. That's on the owner. Why did the ECM fail? I don't know, but having a tuner do stuff to it, not a good idea. I don't know if it's over boosting the fuel pressure. I mean, who knows? But something in there got cooked. The main powers that control the alternator and this fuel solenoid. We have to make sure nothing's shorted out. We can measure the resistance. We can put on a test light, see if we can get the alternator to kick in, how many amps the field circuit draws. So, not, what was the root cause? Why did the ECM fail? Well, if it's tuned and modified, you have to get rid of that first to eliminate that variable. That's the only way to do this, unfortunately. And the owner's like, well, it's been running like that for 6 years. Well, okay. So what? Every 6 years you want to buy a new engine computer? If you want, that's your money. So I guess a couple more checks left here, but we're basically done. So I'm doing a quick check with 200 milliamp test light to make sure that none of the components are shorted to ground or the harness itself. So with this thing unplugged, let's check the low side. So that's not grounded, so that must be a switched ground. And then this is the high side driver. That's not shorted to ground. The alternator, if you plug it in, it should pull the test light to ground through the field sense circuit, or I'm sorry, the actual field circuit. So it's dim there. So we can run it and see if we can get the alternator charged just by putting a test light on there. But this the engine computer is toast. So in terms of checking fuses going to the engine computer, there's only two. One, it's hot at all times, fuse 22. So 22 is right there, ECM 30 amp. That one's actually kind of a mini J case. Obviously that's fine, the truck starts and runs. The other one is 78, that's the ignition on. signal, and that's obviously that's fine. So are we ready to make a $7,000 call here? Yeah, I think so. Nothing wrong with the harness, nothing wrong with powers. I mean, what about grounds? Should we check the grounds at the engine computer? If for this expensive of a call, probably a good idea. I know there's nothing wrong with them, because otherwise the truck wouldn't run at all. But we can look it up on the diagram and just make sure they're good. So checking for shorts to ground on all of the accessories driven by the engine computer, basically all the ones that had codes. Alternator, fuel control solenoid, intake heater relay, and the cooling fan. Let's check those. So for the heater, there's this giant solenoid right there. I got the control wire off of it. I just want to energize it, see how much current it draws on the control side. It's high side switched by the engine computer. We'll see how much current the heater draws, just to make sure that works. Alright, so I have a 4 amp test light connected here. I'm going to power up the solenoid and we'll look at our charger. So right now it's putting out 26 amps. So if I energize the relay, nice big clunk, it maxes out the charger. See the battery voltage drops. So a lot of current going to that heater. And then it recovers. You know, the test lights didn't light up. So that solenoid is drawing, you know, an amp maybe. Not enough to light up the test lights. So that's not a problem. Last thing is cooling fan circuit, control circuit. Again, that's not even a high current circuit, so I'm not worried about that at all. This thing needs an engine computer. So there's a follow-up. If the owner gets it back on the road, I'll let you guys know. Question is, can we make it drivable? As in, energize the alternator with a test light and at least make it temporarily drivable. Let's try out some test lights. We already got the 5 amp test light here. I don't know how much that field circuit's gonna take. If it's a smart field circuit, if it just needs a battery voltage from like a little test light. But yeah, let's see. Alright, here we go. So I got the voltmeter. The yellow lead is on the alternator field wire. So we have 0 millivolts right now. Let's run the truck, and on scan data we're recording alternator voltage and battery voltage. Then I have an assortment of test lights coming from battery positive. We'll touch those to the field wire. You know, that goes up to 1 volt there. While the truck is running, we'll see if we can get this battery voltage up to something reasonable. We're at 12.1. Let's do the 200 milliamp. No change there. Let's do the 1 amp. Test lights are lit. And not really. We try 4 amps. There we go. 12.8, 12.9. Lights are on. Oh, overcharging. Don't want to do that. 2 volts. 2 volts is not enough. 4 is a little too much. We can take out a bulb. You do 2 amps. Okay, it's coming up. So 2 amp bulb. So this isn't a great system because as the battery charges up, the voltage will just keep going up because the field won't be controlled. But it's enough to just let the truck just charge itself for a little while here. That's fine. With 4 amps or 4 volts. You see see as the batteries are topped up, we're approaching 15 volts now. We'll try and plug it. 13. And as the engine revs up, this will go even higher. So, yeah, this is not a great solution. So quick follow-up on the 2014 Cummins with the charging system problem, the fuel pressure problem. Basically all of the high side drivers controlled by the ECM were dead. So how comfortable would you be in calling a bad engine computer? First, let's take a look at how much a new computer costs. I was blown away. So here in ALLDATA, there's the part number, brand new computer, almost $6,300. I'm like, holy crap, I better be 175% sure that this is a bad engine computer. I double checked all of the outputs, made sure nothing's shorted to ground. Everything checked out. So I talked to the customer. I told him, man, I have some bad news. It's going to need a new computer and it's not going to be cheap. So he got the truck towed back and actually found online this website that was recommended on some Mopar forum, autocomputerspecialist.com. And these guys specialize in engine computers. And for example, if you look up Cummins, everything from the oldest, 1990s all the way through the current ones. So he got this 2013 to 14 Dodge Ram Cummins engine computer. So very reasonable, about $1,000. And they actually programmed the VIN, and so it was plug and play. He just had to get a VIN unlock for his tuner, and it was all set. So happy ending. The Cummins is back on the road with a replacement engine computer. So thank goodness people like this exist who provide something, an alternative to the overpriced dealer parts. So this computer rebuilding hopefully in the future will ramp up, so people will have a good option to keep their older cars on the road and not get sidelined by outdated or discontinued or back ordered modules that are very overpriced. So and then he was going to send his original engine computer with the burnt out drivers to my friend Mike Salazar, who specializes in rebuilding engine computers. So we'll see if that shows up on his YouTube channel. But yeah, that's it for this one. So thanks all for watching. We'll see you in the next one. Bye-bye.